Okay, so I gave a worksheet to my daughters, and they got most of the problems correct for the order of operations, but there were a few that they had trouble with, some tricky examples. So I wanted to, oh, excuse me, I just sneezed there. I would like to go over the examples. So, first one, we have 5 cubed plus 7, and that whole thing in parentheses, times 2. So let me just remind you of the orders of operations. The first thing you do is the exponents. So that's, oh, I'm sorry. The first thing you do is parentheses, like this. Next thing you do after that is the exponents, so a to the b. And then you do multiplication and division from left to right. And then finally you do the addition and subtraction from left to right. So what's the first thing we see here? We see a parentheses, so we need to evaluate what's inside this parentheses here. Let me just change the color here. So I can say, okay, we want to evaluate what's inside that. So looking just inside of the parentheses, the first thing I need to do is the exponent, right? 5 to the third power. So 5 to the third power is equal to 5 times 5. Oh, that looks like a plus. I'm sorry. Let me erase that here. 5 times 5 times 5, which is 125 times 5. I'm sorry, 25 times 5, which is 125. So let's just remember 5 cubed is 125. So going back to this expression over here, I've got 125 plus 7. So we've got 125 plus 7, which is equal to 132. And 132 is what's inside the parentheses. So let me just rewrite that. So I've got 132 inside the parentheses times 2, which comes out to 264. Okay? So that's the answer to that one. Let me go on to the next tricky problem. That was, let's see, in parentheses, we've got 5 minus 8 squared plus 6 minus 1. So that whole thing is in parentheses. It doesn't really matter whether it's in parentheses or not, because since the entire expression is in parentheses, it's just as though the parentheses weren't there. So the next thing I have to worry about is this 8 squared. So that 8 squared is 8 times 8. So let me just replace it by 64. So it's important to realize what I mean by replacing it. So I'm replacing this number, 8 squared, by 64. But it still has to come into the expression in the same way. So I've got 5 minus 64 plus 6 minus 1. Now, is there any multiplication or division? No. Is there any addition and subtraction? Yes. And I've just got to go from left to right. So what I've got to do is take 5 minus 64, which turns out to be, remember, a minus b. How you do that? Well, if b is larger than a, then I've got to turn it around and do b minus a and then make it negative. So these things right here, the first two turns into 64 minus 5 is 59, make it negative, so that's negative 59. And then I still have plus 6 and a minus 1. So the next thing I do is combine the negative 59 with the positive 6. So in that case, it's negative a plus b, right? And you remember what you do with negative a plus b? Well, you just turn it around and make it b minus a. Well, that's 6 minus 59. Well then, again, just subtracts the other way. Blah, blah, blah. It's hard to explain, but basically I'm going to do 59 minus 6 is 53, and then make it negative. So I need a new color here. So it's going to be negative 53 for this stuff here. And then I have a minus 1. Negative 53 minus 1, that's a negative a minus b. And you just add them and make it negative, so it's negative 54 is the final answer there. Okay? So that was the second tricky one. Let's go on to the final tricky one from that worksheet for orders of operation. Switch my color back to black. Okay. This was probably the hardest one. So we've got 2 squared divided by parentheses 6 divided by 9 minus 5. So there's a couple different ways to approach this. We know that we need to do the thing inside the parentheses first, but 6 divided by 9 is not a very friendly expression to deal with, because if you have 6 apples, how do you divide it between 9 people? Well, it's going to be a fraction. So what I would prefer to do is just leave it as a fraction. So what does 6 divided by 9 mean? Well, this part right here is just 6/9, right? Because that's what the fraction 6 divided by 9 is, 6/9. So let me just pretend that I evaluated that. I could put, what this number is, which is like 0.6666, etc., as a decimal, but I prefer to just have it as a fraction. In fact, I could reduce it, but I might as well just leave it like that. And then I'll write the rest of my expression. So I got 2 squared divided by 6/9 minus 5. Okay? So I took care of the parentheses by making it into a fraction. Now, the trick here is that, do you remember how to, next thing I do, by the way, is the division right here. Do you know how to divide by a fraction? Well, it's just like multiplying by the reciprocal of the fraction. Do you remember that rule? So we'll have 2 squared. Oh, whoops, I forgot. The next thing I should do is take care of this exponent. So let me undo that thing I just did. Okay, what's 2 squared? 2 squared is 4, because 2 times 2 is 4. So we've got 4 divided by 6/9 minus 5. Now remember, when you're dividing by a fraction, it's the same as multiplying by the reciprocal of that fraction. So this turns out to be 4 times 9/6 minus 5. Now how do you multiply fractions? Well, if you have a whole number, you can turn it into a fraction by doing 4 over 1. So remember, multiplying by fractions is you just multiply through by the numerators and then multiply through by the denominators. So what I end up with is 4 times 9 is 36. So I've got 36, 1 times 6 is 6, over 6, minus 5. Now that's not too bad, because 36 over 6 is equal to 6, right? So 36/6 is the same as 6, so I've got 6 minus 5, which is 1. Now I didn't have to deal with any decimals or anything. So that's why it's nice to leave things as fractions. If I had turned this into a decimal, then I would have had like 4 divided by 4 divided by, 0.66666. And then how do you divide by a decimal? Well, it becomes very messy. So you see, in this case, you really want to keep things as fractions. In the end, just simply get 1. So isn't that a nice demonstration? And what we learn from that is what this guy is saying. He says, keep things as fractions whenever possible. But you might be saying, well, but my teacher wants me to give the answer in a decimal, use my calculator. Well, if you have a calculator, you can do everything on a calculator, but I mean, sometimes you might not have a calculator. Keeping things as fractions is an elegant way to handle this, because a fraction is exact. A decimal, you often only have a couple of decimal places. Decimals aren't as exact as fractions usually. So there we go. Woo!